Hello everyone. My name is Arjun Tiwari and today I am presenting my topic on vision transformer for image recognition, that is in emerging areas in artificial intelligence. A transformer is a deep learning model that uses self-attention and to understand relationship between inputs. It was originally used for text data. This has transformed deep learning architecture that uses self-attention to process all inputs elements in parallel and learn long-range relationship efficiently. And what is vision transformer? Vision transformer is a deep learning model that applies the transformer architecture to divide to images while dividing them into patches and using cell attention to learn global visual features. Uh, Now in vision transformer, instead of text, we apply these ideas to images. Now here you can see the first images. Here you see the first images, original image. You can see the divided into small patches, divided into small patches. Each patches act like a word in a sentence, which help the model to process the image efficiently, step by step. And in the second image, you can see the patch embed. We can apply the patch embedding layer into multiple page patches as 768 dimensional embedding and 196 patches. The width of the ear, this is 224 widths, and this is the image. In this image size is 12 by 12, patch size patch size is 4 by 4, and we can use a CLS token method by transformer. This is process to output embeddings. Uh, Taken, which is the overall image is taken. This is the roughly representation of linear projection of flatter patches. This is the more the cat, dog. So you can understand these type of images, multi-layer perception, layer name, multi-head cell potential, and layer name. This is all the patches. And in the next images, in the next after that, positional encoding. Positional encoding is added to the model, knows its position of each patches in the image, like in the PPT. Applications. This is positional encoding. Positional encoding help us to model to predict all the position of each patch in the images. And then now next move to the second image of the positional encoding. Second image of the positional encoding is the beard images that height and width small patches flatten, and this is the dense layer without activation called patch embedding layer. This is all you know. And comes and go to the third diagram, attention diagram. This is the position encoding the attention diagram. This is the self attention method. Query, key, and value. Q, K, and V are uses to show the position diagram. This the two are used: self dot attention, product attention, and multi head attention. These two are uses. And last is the overall diagram of a transformer encoder. This is the embed to tokens and self attention uses in the. This is all these uses, and now move to the our PPT. Now share to PPT. Applications, this is application like normal detection, sign segmentation. In medical images, we can also use tumor detection, X-ray detection, autonomous vehicles, and now vehicles are running on self-attention models like radar and all. That is also uses. And facial recognition and surveillance like cameras and all, CCTV cameras and facial recognition in mobiles and laptops that uses the face recognition to identify all the unlocks and all. And that is the behind the working principle I show you on the images. Divide images. The image is split into fixed size like 16 into 16 patches and flatten and emitting. Multi-art self-attention with UV. I show you these images. I shown that this images. This Q and V self-attention uses self-attention. And architecture. This is the 50 representation of architecture. This is the full architecture transformer I showed in the images. This architecture. And let's end the topic. Advantage of vision transformer captures global context, better understanding for entire images. Scalable performance improves with larger datasets and computation. Flexible, we can integrate with other models like text, audio, and last, reduce inductive bias compared to CNS. Models learn feature automatically, and model over uses limitations and challenges requires large dataset and computation power. We require large dataset in Kaggle वगैरह less less effective and small dataset without retraining. Training time can be high. Ongoing research hybrid models. This is the reference pages we use is reference paper from accessibility at AL and images worth patches. These models are used basically these models basically it's an end of the PPT and end of the business transformer. The main advantage is that they understand the image globally, but they require large datasets and high computation. These models are also used like object detection, medical imaging, self-driving cars, and face recognition. So in conclusion, vision transformer are a powerful modern approach that use attention to understand images more effectively. That's all for today. Thank you so much.